We are now, TMS is very pleased to have the Council of Competitiveness joining us in the summit. And I would now like to introduce Chuck McDougal, the Senior Vice President of the Council, to tell us a little bit about the efforts in the manufacturing area and also to introduce our dinner speaker, Jim Phillips. So, Jack, please come up to the podium.
Well, good evening, and thank you, Wolfgang, for your warm introduction. I'm very pleased to be with you here tonight, and I look forward to our important and provocative conversations tomorrow. On behalf of Deborah Wynn Smith, our CEO, and all of us at the Council, I want to thank Warren Hunt and his team here at TMS for this opportunity, and we look forward at the Council of forging a close collaboration with TMS in the months and years ahead. I also want to acknowledge all of the Council member organizations that are here with us tonight, as well as others that have taken the time to join us. I especially want to recognize one of our key members, Jim Phillips, Chairman and CEO of Nano Ice, who you'll hear from in a few minutes. And I'd also like to recognize my colleague, Walt Kirchner, the Council's Chief Technologist in Residence, and he's on loan to us from Argonne National Lab, and Walt will be with us tomorrow as well. And I'd also like a shout out to Cyrus Waddy, who we've been working with closely at the White House Office of Science and Technology Policy. Thank you for your leadership role in the Materials Genome Initiative, and we look forward to working with you on that project as well. For those of you that are not familiar with the Council, we're a nonpartisan, not-for-profit organization. We have 160 members, which are CEOs, university presidents, national lab directors, and labor leaders, focused on improving U.S. productivity and our standard of living. We're very fortunate to have Sam Allen, Chairman and CEO of Deere & Company, serving as our chairman and leading our current manufacturing initiative. I think Brent Augustine from Deere is here with us from Deere's Metals and Mechanics Group, so we look forward to talking with you tomorrow as well. Since the Council's founding in 1986, competitiveness has become an even more important concern as America and the global economy continue to face extraordinary challenges and opportunities. The Council is very pleased that so much of today's national conversation is focused on ensuring that the U.S. remains the world's most competitive marketplace. In December, the Council released its report on manufacturing called MAKE, an American manufacturing movement. MAKE is the culmination of 18 months of in-depth conversations and multi-day dialogues with more than 400 senior manufacturing leaders and others who provided critical insights on the policies and practices necessary to ensure continuing American manufacturing leadership. The Council's other critical initiatives are also integrated into our manufacturing work, including our Technology Leadership and Strategy Initiative, which is composed of nearly 50 Chief Technology Officers, our High Performance Computing Initiative, which focuses on driving the transition to an exascale economy, the National Digital Engineering and Manufacturing Consortia, which is bringing advanced modeling and simulation tools to small manufacturers across industry, and a variety of programs focused on developing the skilled workforce needed to spur innovation and expand the American manufacturing enterprise. And our MAKE report is only the beginning of our manufacturing journey. The Council will continue to pursue these efforts over the next several years to force a dynamic future for Americans through a new era of production excellence. In our report, we issue a call to action for the President, Congress, governors, and the American people, and we're making significant progress in influencing the national conversation on these important issues. More than 1,000 hard copies of MAKE have been delivered to every member of Congress, every governor, every cabinet secretary, and many other influential leaders across the country. We continue to work closely with the White House and other executive branch agencies to establish the environment needed to grow U.S. manufacturing. We presented MAKE at the annual Congressional Democratic Caucus Strategy Meeting and plan to do the same at the upcoming Republican Caucus Strategy Meeting. The press release announcing MAKE was read by more than 14,000 outlets. We plan to discuss MAKE at the 2012 National Governors Association annual meeting, and we're preparing a series of manufacturing town hall meetings across the country with governors and U.S. senators, and in April, we will have the first two, one in Tennessee and the other in New York. We are also establishing a national manufacturing coalition to expand our reach and raise our collective voice. We hope to include organizations such as the Society for Manufacturing Excellence and, of course, the Minerals, Metals, and Materials Society. We will continue our manufacturing dialogues this year. Topics to be explored in addition to advanced materials tomorrow will include cyber-enabled manufacturing, advanced manufacturing technologies and processes, talent-driven innovation, accelerating and innovating workforce development, additive manufacturing, and we'll launch a series of over-the-horizon dialogues exploring the nexus of food, water, energy, national security, and manufacturing. So we have a very busy agenda. The Council applauds the increased public and political attention given to manufacturing. Not only did President Obama devote significant time to manufacturing in his State of the Union address, but Republican presidential candidates also routinely talk about manufacturing. Manufacturing is again fashionable, though we must ensure this endures beyond political cycles and that the United States fully responds to the challenges affecting our economy, in particular, supporting manufacturing. Part of the ongoing challenge facing manufacturing is one of perception. American manufacturing is either in steep decline, doing reasonably well, or poised to grow. Widely available reports and analyses support each of these conflicting views. Depending on the analysts consulted, data used, or time periods examined, various conclusions can be drawn about the health and importance of American manufacturing. So it's no wonder that policy prescriptions for manufacturing over the years are often in disarray. But one thing is clear. Manufacturing is a critical sector of our economic portfolio, and the increased national discussion about manufacturing is both overdue and very welcome. Manufacturing is a cornerstone of American independence, economic prosperity, and national security. It drives the largest and most technologically powerful economy on the planet, ours. U.S. manufacturing is growing, in fact, up to $1.8 trillion in output in 2011. It's a global market engine, accounting for 60% of all U.S. export value. And manufacturing has the highest multiplier effect of any industry. For every dollar in manufacturing value added, $1.40 in additional value added is created in other sectors, such as agriculture, mining, construction, services, transportation, and more. The image of manufacturing as dumb, dirty, dangerous, and disappearing is wrong. Today, manufacturing is smart, safe, sustainable, and surging. In our MAKE report, we offer a number of important insights that I'd like to share. Manufacturing at scale is a critical piece of the full life cycle innovation process, and the United States must create the necessary environment to encourage manufacturing at scale and ongoing operations. This is part of the overall R&D innovation process. There are multiple valleys of death as companies work to scale up in America. In several of our dialogues last year, it was noted that financing for American manufacturers becomes increasingly difficult as revenues approach and exceed $100 million, often forcing these companies to find funding from foreign sources, in particular, powerful sovereign wealth funds, which only siphon off U.S. innovations. Affiliate sales in 2010 were 3 times U.S. exports. While exports are critical, U.S. policy must recognize that affiliate sales are also critical to enter markets, grow market share, and maintain excellence throughout global supply networks. Future manufacturing is not about bringing jobs back or restoring what's been lost. It's more about defining a new vision and creating new jobs. There will be ongoing tension between productivity gains and job creation. It is likely that the job multiplier will increase more than the number of direct manufacturing jobs increase. The 3 most important barriers or significant barriers that we uncovered to growing manufacturing at scale in the United States: taxes, regulations, and access to skilled workers. An interesting point is that companies are becoming much more sophisticated in understanding the total cost of production, which is providing the U.S. with an opportunity to improve its strategic advantages, especially in areas of R&D, intellectual property protection, quality management, and in many cases, driving shorter cycle times. In 2010, the U.S. was the #1 destination for foreign direct investment, much of it from Europe, and only 30% of outbound U.S. FDI goes to Asia. We all know that U.S. and global manufacturing are in deep transformations. High tech infuses every step of making and delivering products: digital design, modeling and simulation, 3D imaging, robotics, artificial intelligence, machine vision, digital controls, sensors, material by design, and so on. Nanotech and biotech revolutions are unfolding, opening a new era of science-based manufacturing that will disrupt production, supply chains, product markets, industries, firms, and labor markets. These breakthroughs are likely to reorder production even more significantly than the changes brought about by digital technologies. In particular, materials science offers the prospect of morphing every aspect of modern life, much as it has done throughout history. The progressive use of more sophisticated materials creates an innovative and economic divide between societies, one that we must capture for our benefit. Stone Age cultures began developing tools which enabled early adopter nomadic tribes to build prosperous permanent settlements. The innovation of smelting and casting metals in the Bronze Age further changed the way cultures developed and interacted with each other. In the 10th century BC, glass production started in the Near East. Steel making became widespread in China in the 2nd century AD. In the 8th century, tin glazing ceramics invented by Arabic chemists and potters. Glass lenses were developed in the Netherlands and used for the first time in microscopes and telescopes in the 1500s. In the 17th century, Galileo publishes 2 new sciences focused on the science of materials. In the 1700s, patents are issued for the production of metallic zinc, hydraulic cement, and copper-zinc acid batteries. In the century after that, we saw metallic aluminum, vulcanized rubber, silver-based photographic processes, and the first solar cells using selenium, not to mention many other innovations stemming from petroleum-based products. In the post-World War II era, polymers advanced particularly fast, and material science became a new interdisciplinary field in its own right. With this awesome breadth of history behind us, we are on the edge of even greater and perhaps unimaginable discoveries in material science. For example, 2 I came across recently that I thought were particularly interesting. It's amazing what a molecule can do. The metal organic framework, a molecule developed at Texas A&M, looks like a simple table salt, yet it actually has the highest internal surface area of any known substance on the planet. A single MOF could cover a football field if unfolded. It's also the most porous material known to man. These qualities could make MOFs the key to better hydrogen cars, carbon capture, and storage technologies. Another example, nanofabrication, which Jim will discuss in greater detail, is being used to make better ice for food storage. We've all heard of making a better mousetrap. Well, now we're making better ice cubes. Nano Ice is a technology invented in Iceland 10 years ago, and it's now being commercialized in the United States. The ice is made up of tiny crystal particles about the size of a bacteria, and the frigid fractions immerse perishable foods completely. The generators to produce Nano Ice use 90% less refrigerant and 70% less energy than conventional ice-making machines. Plus, the ice extends the freshness of perishable foods by more than 2 times. Innovations in material science and the transformations to a new era of materials by design will change practically everything we know and everything we do. The question is, will the United States capture the full life cycle benefits of these amazing innovations and manufacture the products here? Or will we continue to be the innovation engine for the rest of the world, eventually leading to the decline of a prosperous nation? I'm sure we will get all of these questions answered tomorrow. I'm looking forward to our upcoming discussions and again want to thank everyone for taking the time to participate. Thank you.